Here you go. We are recording.
All right, so hello everyone. I had suggested tomorrow that we do a discussion about, or I would do a discussion about coercion in R, and that he pointed out to me this video that Hadley created, as is very typical. Hadley has already done the same exact idea that I had, and but much better than I would have done. So we thought it would probably be good to just watch the video that he did, which really clearly explains some of these concepts, and then we can have a bit of discussion afterwards and maybe also try to frame it in a little more practical sense, because I feel like the video is fairly conceptual, but yeah, so definitely a good starting point. So we'll just go ahead and start the video. And doesn't want to run. Okay.
Classic.
Yeah. Okay, I guess you have to hit play first. So there you go.
So today I wanted to talk about a new package that I've been working on called vectors and this associated idea of type stability, which basically means that ideally it should be easy to predict what type of thing your function returns. But before we get into that, I want to talk a little bit about the motivation in terms of some WATs. How many of you heard of WAT before? Okay, WAT is like what or W3F, but even more surprising. And there's a really great talk at this URL that kind of created this term. They're talking about some of the really surprising things about Ruby in JavaScript. And so I'm going to show you some really kind of crazy stuff in R, and this is sort of the motivation. So I'm going to show you a little bit of code. So here I've got two factors, and I combine them together. And what do I get? All right. You might hope that I get an A and a B in there, right? And hopefully maybe the output would be a factor. You probably did not expect to get 2 1s out of that. Well, what happens if I take a date and a date time and combine them together? It took me a while to even kind of like figure out what was going on here, but this is a date. In the year 4,200,937 on the 24th of January. Or what happens if you do the other thing? What happens if you combine a date time with a date? Again, we get the date time that I gave it, and I get this weird date in 1969. But what happens if you even look at a date time the wrong way? So what happens if you take a date time and just concatenate it with nothing? You lose the time zone. Well, what happens if you combine it with a literal nothing, a null? Oh, you get this random number. So I seriously hope that no one would argue that this behavior is correct. I think there's some kind of good reasons of this. There's not great reasons, but there's sort of some accidents of history that have led us to this place where we can get some pretty surprising results from like pretty unsurprising data types and a pretty unsurprising operation. But so what's even kind of worse about this is I've just shown you one function, but there's a bunch of other places we have to do this. You've got to take 2 vectors of different types and combine them together. You get this in unlist and rbind and if-else and merge and a bunch of other places. And I don't mean to just pick on base R here, but tidyverse has exactly the same problem, that some functions of combining 2 vectors together do something different to other functions, which is clearly a really, really bad thing. And so the kind of the motivation for this vectors package was to think about, well, like what should we do? This is clearly crazy what currently happens. Like how can we do better? Like, what should we do? And I think we can get some hint of that by looking at the rules for for C, for concatenate, for atomic vectors, because the rules here are like pretty simple and pretty reasonable. And here I've kind of displayed them in painful detail. If you've got logical and logical, you get a logical. If you've got logical and integer, you get an integer. And if you just list them all out like this, it seems pretty complicated. But you can kind of display this in a table form too. So if you've got a logical and a logical, you get a logical. If you've got a double and a character, you get a character. And if you stare at this table a little bit, you'll notice that it's actually symmetrical. And that's a really nice principle, right? Because it means, in this sense, it means it doesn't matter which order the arguments are, you're going to get the same type of output. And it means you've got like a lot less you've got less than half of the table to remember. And that also means we can actually express it even more simply. We can express it as well, this is technically a tree. This is a very simple tree. It's a tree with no branches. I'll show you a tree with some branches a little bit later. But you can you can sort of work this tree by, if you've got like a logical and a double, say, you kind of follow the arrows until they meet up at a common place, which in this case is a double, right? So you can just put your finger on the two types and then follow the arrow from one to the other to know which type you're working. And so now this is a pretty simple summary of the rules that base R pretty consistently applies to atomic vectors. And I think even if you've never been explicitly taught this, you've probably like kind of picked it up implicitly because this rule is consistently applied. The problem with C, however, arises that when we start to get to these more complicated S3 vectors, which are built on top of these atomic vectors, that there aren't any kind of simple rules anymore. So when we get to factors and date times and data frames, things start to get more complicated, and it is exceedingly difficult to elucidate the complete set of rules. So figuring out what the rules should be, at least in my opinion, is the goal of this vectors package. And I don't know, the thing I like most about this package is possibly the logo, which is very Tron inspired. So the goal of vectors is to kind of figure out these principles kind of like once and for all, to apply them everywhere. And the goal in some sense of vectors is a little bit weird, because I think if vectors are successful, and it becomes this consistent set of rules, the package itself becomes invisible. So my goal is that you should never ever have to know that this package exists. But I want to talk, but unless you're a package developer, unless you start to dive into the details, we can start to now learn this pretty simple theory. And the basic idea of vectors is to take that very simple tree we had before, that line, and basically kind of turn it into a forest. So again, the same principles apply. If you want to combine two types of vector, you put your finger on each one, and then you follow the arrows. So you will notice, however, that this is not like a tree, this is a forest. Some of the things are not connected. You cannot put your finger on factor and double and find any way to go between them. And I think this is really, really important. There are some coercions that simply do not exist. There's no way that it makes sense to combine a factor and a date time together. Instead of like trying to do something, trying to guess at what you mean, it's much safer to get an error that forces you to confront the fact that you've got a mix of weird data types. You have to deal with that yourself. So I'm going to do a little demo of this. No, live demos are always risky, but this should be fairly safe. So I've got the vectors package loaded, and basically, I'm going to show you this function called vec_c, which is basically the same as a C function you're familiar with from base R, but obeys this consistent set of rules. So if I get a logical and an integer together, or logical and a double together, I'm getting double. If I take a double and an integer, I get a double. Right? These are the kind of the rules that you're already familiar with. You don't even have to think about them. It is a little bit stricter about coercing the character vectors. So if you try and combine a double and a character together, you get an error. This is unlike base R, right, where you can just combine these things that are a little bit different together, and R will just kind of do it for you. So vectors is a little bit more strict in general because it has this kind of escape hatch. All of these vectors functions allow you to declare the desired prototype of the output. So here I can say, actually, I want the output to be a prototype, this character type. And I call this kind of a prototype because you don't give it a name of a type, you give it like an example of a type. So here I'm saying, I'll make sure the output looks like an empty character vector. And so I can do that, and now instead of implicitly coercing vectors to a common type, here we're going to explicitly cast to the type that we have provided it. So now we have this consistent way that you can say, I want to make sure the output is a character vector, and it will either be a character vector, or you will get an error. You will never get any other type of output when you call a function this way. So again, we get the same kind of similar property with factors. We can combine them together. We always get a factor back. Now note the order in which we combine the factor is important because the levels are different, right? So if I combine A and B first, the levels are A and then B. If I combine B then A, the levels are in the opposite order. So it turns out it's kind of not possible to be like completely symmetric, because the only option here, if I wanted to be completely symmetric, is I think I'd have to sort the factor levels, which seems like a really, really bad idea. Not very useful. So the thinking behind vectors is kind of a combination of like philosophy and pragmatics. There are some things that would just be like maybe kind of philosophically more beautiful or more pure, but pragmatically would just cause you a bunch more pain when trying to use this in your code. And so vectors tries to kind of balance those things, tries to steer you in a direction of greater safety, of greater strictness, of this idea of type stability, which I'll come back to shortly, and away from just kind of always working, doing whatever happens. So the same thing works with ordered factors. If you try and combine a factor and an ordered factor, you're going to get an error. You can combine factors and characters, or again, you've always got this escape hatch. You can say, if there isn't an automatic coercion that exists, I can always say, I want the outputs to be of this type. So again, vectors is going to be more likely to give you errors than base R is, because it gives you the standard way of resolving those errors by explicitly declaring the type of output that you want. And again, with dates and date times, this is like basically the most boring demo ever, because it just does what I think any reasonable person would expect it to do. If you combine dates and date times together, you don't get crazy dates far in the future, far in the past. And if you just concatenate a single vector with itself, then the time zone's unchanged. And then when you try and combine different things in base R, I kind of showed you a few of these before. But if you combine a factor and a date time, you get an integer. If you combine a date time and a factor, you get a date time, a date with a weird date. I mean, vectors just always gets you in right. And again, and this is always this other kind of one last escape hatch, like what happens if you really do want to combine a date time and a factor into a single vector? Well, you can always fall back to a list, because a list in R can contain anything else. So we can always say, make sure the output is a list, and we'll just combine all these things. So the kind of underlying idea behind vectors is this idea of type stability, which I'm still trying to figure out how to express, articulate as clearly as possible. But I think this is this principle. The way I sort of think about it is like when you're reading R code, what you are actually doing is running that R code in your internal mental model of R. And obviously, your internal mental model of R is much, much simpler than the real thing. But I think in your internal mental model of R, one thing that's really useful to think about is the type of each variable. And I notice that when I read other people's code, when I'm reviewing pull requests, for example, if I read the code and I look at a variable, and I have no idea what type of variable it is, I don't know if it's a list or a character or a data frame, that code just feels very dangerous to me because I cannot accurately predict what's doing. So the first principle of type stability is that the output type should only depend on the types of the inputs. And so one kind of violation of this in base R is the if-else function. So here I've got 3 calls to if else. The first argument is always logical. The second argument is always integer. The third argument is always a character vector. And yet, depending on the value of the logical vector, the output could be a logical vector, it could be a double vector, it could be a character vector. And I think this is an undesirable property because when you read code that involves if else, it makes it hard to know what type of output. And again, I don't want to say like the tidyverse is perfect, it's far from perfect. dplyr if else actually is equally annoying, but in the opposite direction. It's like too strict, which forces you, if you want to insert a missing value, to know about all of these different types of missing values that you should never be forced to confront. And that's pretty annoying. The second principle is that if you're just combining a bunch of vectors, or your argument has ... in it, and your function has ... in it, the order of the inputs should not affect the output type. So I kind of showed you an example of this already, or lots of examples of this with C, but ideally, the order in which you supply arguments to C should not affect the output. This is the idea that gave us that symmetry in the table. This makes predicting the output much, much, much simpler because it's just a much smaller set of rules that you need to remember and internalize. And again, the goal here is not that you should ever have to explicitly memorize the rules, but hopefully by having this small set of like reasonable and consistent rules, you will just come to learn them over time. And when you predict, when you like guess, your naive guess about what a function will return should just be more accurate. And then the final principle is almost so obvious that you shouldn't have to recognize, you shouldn't have to say it, and that is ideally there should be one set of rules that is applied everywhere. So again, just to illustrate this, if you concatenate 2 factors together, you get an integer vector, but if you put those factors together in a list and then you unlist them, you will get a factor as you expected. So the fact that we have these inconsistencies just makes it hard to build up that accurate mental model and it gets confused. And I think there's sort of both this like first order effect that when you like look at some code, you're like, oh, I don't know what this is going to return. But you also get the second order effect that's even worse, that over time you sort of get this like learned helplessness. You're like, I have no idea. I've been burned so many times before, I've got no idea what this is going to return. So I'm just not even going to try to guess, which I think is even more harmful. Now, vectors does a bunch of other things, which I want to talk about briefly. Max really wants to give me the gong if I talk too long, so I don't want to.
We're going to give him the gong. Okay, so can everyone hear me?
Yes.
Really quiet. But so yeah, that was Hadley's take on vectors, but it's largely driven by this concept of coercion that I want to talk about. I think in his talk, what's driving the vectors package is some of these like maybe not quite edge cases or particular cases of concatenation by coercion with dates and factors. Those were the primary things that seem to drive him to make this package. But I also, my interest in it was kind of about this initial graph that he made that he said is symmetric and very easy to learn. But I think that's something that you do kind of learn implicitly, but you don't necessarily think about very consciously very often. And I think that there's some interesting maybe features of that in the way that R does do some coercion automatically in a lot of cases, but then also some potential gotchas. And that's even in this original part of it that Hadley seems to be pretty comfortable with. I think there's also some interesting things in that. So I thought we would just have a discussion and yeah, ask any questions, or if anyone has any examples of things that they run into using around this kind of topic, coercing data types, or does anyone have anything interesting?
We just kind of ran into it when I was speaking with you. with the when we were doing map to logical, and I was
Yeah.
mapping NAs to logical, and it was kind of jumping up, I think, in that tree automatically. And so the output, it was outputting NAs, but the type of the NA wasn't matching the type of the rest of the output of that function. Which is pretty annoying and weird. Yeah.
And he briefly mentioned this dplyer's if-else function is very strict about the data type. So you have to, even if you want to insert an NA, most R users are just used to typing capital A and capital A, and they expect it means NA everywhere. But there are actually these internal NA logical, NA integer, NA real, etc. that, and I learned that day that there is no NA logical, which I just assumed there was, but there's not. So it's the types is kind of interesting. In a lot of languages, you have to be very specific about what a variable is when you create it, and a lot of them you can't even change it. Whereas R, you can create a factor variable and name it X, and then you can put an integer into it or put a character into it, and it just overwrites itself and becomes another data type. You can throw it into an expression, like you can add it to a number, a character to a number, and it usually doesn't error. It just does something, which it can be really surprising in a lot of cases. It can be kind of nice because in some cases it means you don't get an error and everything doesn't stop. But it's also dangerous because sometimes that's something maybe you do want to error because clearly you weren't trying to add those things. But yeah, so I think it's a pretty interesting topic. I just today was working on this because we have these BICS codes, which are all numbers, but technically, at least from my perspective, conceptually, they're not numbers. They are numbers, but they're not. And numbers can be characters as well. They are part of the character encoding, so you can easily, he's in his talk here, he seems to think that's very wrong to coerce a number into a character. Like that should only be some very explicit case, but that's exactly what I was doing today. Because I was reading in numbers, I'm like, these are not numbers, they should be characters, because conceptually they're not really numbers. So I coerce them into characters. So does anyone else have a?
I mean, I run into that problem a lot with but usually it's because I'm missing some element. And so I guess a good example is with fund data, some files, they don't have any XML. I mean, they don't have any ISINs in there. And so for a while I was getting frustrated out of my mind because of it, but then I realized I just need to, because I tried first inserting an NA, and then of course it gives me we have character and logical, this doesn't work. And then I realized, just insert NA character. And solved it. But
there was also something, so I had some ideas of things that are very similar to this concept of automatic coercion that R does. And Hadley, I stopped him there, but he does make mention of this with the recycling of vectors. So you know that if you add a vector you have a vector of integers that one is 3 elements long and one is 2 elements long. If you add them together, you'll get a 3-element vector, and the 2-element vector will be repeated until it's enough to fill up the vector. So this is another really,
that seems like a weird one.
It's a really weird one. And this is another thing where it's super useful in a lot of cases. It's super convenient because sometimes that's really what you want to do.
Yeah.
Like if you want to add 1 to every odd number and 2 to every even number, you can very easily do that in R.
Yeah.
So there are some useful cases, but it's also, again, one of these things can be super dangerous because sometimes it's totally not what you're expecting. What really happened is there's some error somewhere else, but it's running through, and you're like, how can this possibly work if it's wrong? So yeah, that was another thing that's similar to R's form of automatic coercion that I was going to bring up. Oh, we've been upgraded. So does anyone remotely have a comment or?
No, I just had a very interesting case where I pulled the column names of my data frame, and they were all clearly names, and it converted them into integers. So I hit into an error because I was expecting its characters, but I'm not sure how can use this package now to make sure that happen? Like, would I, if I do the pull function, would I, like, how do I make sure that, how do I apply this package basically to make sure it's characters, or, I mean.
So the motivation for showing this video was not to specifically encourage anyone to use this package per se. My impression is that this package is targeted at package developers that want to have like really robust management of their vectors within their package, and not something that like an end user would necessarily be using, and probably not something that an analyst would be using it in their own code, unless they also just really wanted to be sure about what's happening with their vectors. But I don't know if it's really necessary. So I generally, I think the topic is interesting. His motivation for making this package was more why I wanted to, and his explanation of that is why I wanted to share this video. As far as like implementing the ideas in a practical sense, I'm not saying specifically to use this package, but to keep in mind these ideas about what happens when you combine different data types. And if you're not using this package, you can just, for instance, if you use pool and then you have a vector that comes out of it, you can add a step where you could coerce it to the thing that you know it should be, just as a cautionary step.
Yeah, I mean, that's what I'm doing, basically calling as character directly at the beginning now. No, I mean, the topic is super interesting, and it's like, I mean, it happened to me in the past 5 days, probably like 20 times, that there was some weird thing happening in terms of what type of format it used, like our R is using.
Yeah. And I think that, at least in my experience, that usually happens when you combine some things and these automatic coercion rules are occurring when you don't necessarily realize they're happening. And that's when it really can catch you. So yeah, my best advice in that case is just to be really, once you do your entire chain of actions that you're doing to get where you want, then the last thing is you make sure you coerce it to the thing that you actually expect it to be. And that's maybe the best way to prevent this from happening. But it could also be an indication that somewhere along the line you're combining things that maybe you need to think about, make sure it's what you actually really want. Yeah, Maro?
Couple of minutes away from the half past. So thank you very much for exposing these problems, that at least, by being aware of it, I guess that people will be more careful. Sometimes, we blame ourselves, what I'm doing wrong, but actually R itself has a lot of things that can bite you. So I'll leave you these 2 minutes to wrap up.
Okay,
CJ.
so yeah, that's it for me. As far as the tag, I don't think this is necessarily an absolute must-have, but it's an interesting topic, and something that probably all of you are going to deal with now and then, but it's not I don't think this is a must-have. And with that, I guess I'm done. So thanks, Maro, for recording, and we'll see you next week.
Thank you. Thanks very much.
Thank you.
Ciao.
Thank you.
Ciao.
Thanks, CJ.